In partial fraction decomposition, we have four cases. And if you really look at it, we actually have two with two different types. The first two deal with linear factors, which is things like x plus 1. And then when they're repeated, we get x plus 1 squared, and so on. These two deal with quadratic factors, which are things like x squared plus 1, x squared plus 4. And notice that these are irreducible. Because if you had a reducible quadratic factor, you would just go ahead and reduce them and you'd be back to the original two cases. So along with our repeated reducible, we're going to take a look at each one of these four cases and do an example for each one. So in our first example, we have just linear factors. They're not repeated. The denominator is a product of linear factors. So if we notice, we have these linear factors lined up here. And here they are as they're decomposed into their partial fractions. And we use A, B, and C, and that's what we're going to determine in each case. So let's look at an example. We have this integral here, x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x. So the first thing we want to do is take a look at the fraction, make sure that we don't have to do any long division. And that would be when we have a higher degree in the numerator than we do in the denominator, which is not the case. So we can just go straight to the partial fraction decomposition. In the first step, we're going to take our denominator, 3x squared minus 2x, and we're going to need to factor. And when we do that, we're going to take x, 2x squared plus 3x minus 2, and if we factor that, we should be able to take 2x and x, and notice we got a 2. We need a positive 3 when they add together, so 2x minus 1 times x plus 2. And that's our linear factors. So now we can look at this. We can break this fraction down, and we'll do that down here. X squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x is equal to, well, now we've got our linear factor that we can use to break this down. We get 2x minus 1 for that one, and x plus 2 for the third one. Now, what we need to do is multiply by the denominator. And when we do, we will have just the numerator left on the left-hand side. But now we get all of this over here on the right-hand side. So we need to state it all out. A times 2x minus 1 plus 2x minus 1 times x plus 2 plus b x times x plus 2 plus c x times 2x minus 1. So now let's go ahead and multiply this all through. And when we do that, we're going to get a times 2x squared plus 3x minus 2 plus b times x squared plus 2x plus c times 2x squared minus x. And then we need to group all of our variables together. So we have the x squareds. So we're going to group all of our x squareds. We're going to have the first term is going to be 2a plus b plus 2c. Let's group all of our x's together. When we do that, we're going to get 3a plus 2b minus c. And then we just have our singular minus 2a. Now we need to equate them to our original numerator over here. So that means we're going to have 2a plus b plus 2c is going to be equal to 1, because that is the coefficient in front of the x squared, we're going to have 3a plus 2b minus c, that is equal to 2. And then minus 2a is going to be equal to minus 1. Well, let's start with the easy thing. We can look at this and say x is equal to 1/2. So that's easy. So let's take it back up to our first two equations, and we get 2a being equal to 1. So that means that b plus 2c is going to be equal to 0. 1 minus 1 being 0. 3 halves, so we're going to get 3 halves. We need to subtract 3 halves to the right-hand side, and we will get 1/2 over here with 2b minus c equal to 1/2. Well, to eliminate c, we're going to multiply the second equation by 2, giving us 4b minus 2c is equal to 1. Add those together, we get 5b is equal to 1. b is equal to 1/5. So now we just need to substitute it back into one of our equations over here. In fact, I'm going to take this one, and I get 1/5 minus 2c is equal to 0. Bring that over to the right-hand side, and we should get 1/10 is c. So now we have our coefficients that we can use in the partial fraction. So now we can finally set up the integral. We're going to get integral of, in fact, let's put the 1/2 over here. So the integral of 1 over x dx. 1/5, since that's b, 1 over 2x minus 1 dx plus 1/10 integral of 1 over x plus 2 dx. All right, well, we know this one is going to be pretty easy, this one's going to be pretty easy, and this one has a substitution that we'll have to do with the u being 2x minus 1. When we do that, you notice we're going to have du being 2 dx. So when we divide by 2, we're going to get an extra 1/2 that pops out of this. And that's going to give us 1/2 natural log of x for our first one. 1/2 times the 1/5 gives us 1/10 natural log of 2x minus 1. And then 1/10 natural log of x plus 2. And that is our integral. Okay, let's look at repeated factors. What happens when we have a repeated factor? We just repeat it. So x plus 2, in this example, x plus 2 squared, because we had x plus 2 squared right here, and it's just a, b, c. Nothing really special. We just have to make sure that we repeat the factor that actually has more than 1 in our denominator. So let's look at this example. We have x to the 4th plus 2x squared plus 4x plus 1 over x cubed minus x squared minus x plus 1. Well, if you notice, we have a degree of 4 up here and a degree of 3 here. And so we need to do some division. And what we can see, if we work out the long division here, x cubed minus x squared minus x plus 1, take us back to our calculus days. This is a minus 2. That is a minus. We need a minus 2x. Let's make that a minus. Plus 4x plus 1. All right. X for the first one, so we're going to get x to the 4th minus x cubed minus x squared plus x. We need to subtract. So we're going to subtract all that. That'll give us nothing. This will give us a positive x cubed negative 2 plus 1, negative x squared. 4 minus 1 gives us the 3 plus 1. Now we can take another 1 out of this. That seems to work out pretty well. Once again, we're going to subtract everything. That gives us 0. That gives us 0. 3 minus x, or 3 plus x. 3 plus 1 will give us a 4. And this will give us a 0. So what we have now is the integral of x plus 1 dx plus the integral of 4x over our denominator. And that's what we're going to be looking for. So we're going to do the partial fraction on this one, and we'll pick this back up when we're done. So let's set it up. Well, we need to factor our denominator. When we do that, this is factored by grouping. If you notice, we have x squared, or x cubed minus x squared. We can take an x out of that first term. We can actually take an x squared out of that first term and get x minus 1. And we can take a minus 1 out of these last two terms and get another x minus 1. And so when we group them together, we're getting x squared minus 1 times x minus 1. And that's not irreducible, that is actually reducible. So we're going to reduce that, meaning we're going to factor it out. And notice we have two x minus 1s. So let's do x plus 1 times x minus 1 squared. Okay. So let's set up our partial fraction decomposition. So we're going to have just like before, we're going to have rewrite our fraction here, set up our equation, and we're going to do x minus 1 having the a, x minus 1 squared. So remember, we have a repeated factor. That's going to be our b. And then x plus 1. That's going to be our c. So in order to save time, I'm going to leave the algebra to the student. And we're going to just go straight to our factors, which is going to be a is equal to 1, b is equal to 2, and c is equal to negative 1. So now let's work on our actual integration. Remember, we had the x plus 1 dx from before plus a. So that was 1 x minus over x minus 1 dx plus 2 integral of x minus 1 squared dx, and then a minus 1, and we get x plus 1 on the denominator for our last one. So now, let's just work straight through the integration. Well, we get, when we integrate this is just normal. This is 1/2 x squared plus x plus the natural log of x minus 1. Here we had a little bit of a substitution that we had to do. We actually had the integral of 1 over u squared du. U being x minus 1. That makes it pretty easy to see that this is going to be negative 1 over u, or negative 1 over x minus 1. And actually it should be 2 because we got that 2 out in front. And then our last one is, again, pretty simple. Natural log of x plus 1. And don't forget your constant. So now, that is the second case. Here's our third case, the irreducible quadratic factors. And once again, we have an x1 minus 1 that's repeated. We also have this x squared plus 1. So again, in order to save time, I'm not going to go through all the steps again, but we do have x cubed plus 4x. We can see that breaks down here in this example. We can take an x out of it and get x squared plus 4. So that's our irreducible factor. And so when we break this down, we're going to have, let's do 2x squared minus x plus 4. Let's just get the whole fraction set up. Of course, we have x to start with on the a, and then x squared plus 4. That gives us the bx plus c. So when you work through the algebra, once again, you're going to have a is equal to 1, b is equal to 1, and c is equal to negative 1. So the integral is going to work out to be 1 over x dx plus the integral of, with the x squared plus 4 in the denominator, b is 1, so that's x. C is negative 1, that's minus 1 dx. Well, fortunately, we got to break this up. We can break it up because of the linearity of it. So we're going to bring this down, not quite integrate just yet. X squared plus 4, we're going to have the x first. And then here, x squared plus 4 with the 1. And these two we can handle pretty well. This one we know, this one is integration by substitution. So that should be pretty simple there. But what we're going to get on this one is we have something special. So we're going to look at this formula real quick. Is the integral of x squared plus a squared is equal to 1 over a arctangent of x over a. So we're going to use that formula here in a minute. Let's work through the substitution here. We should get u is equal to x squared plus 4. That's our denominator. Du is equal to 2x. And so 1/2 du is equal to x dx. And we have that right here in our original integration. So now we have natural log of x. We have a 1/2 that's going to come out of this. And we're going to get natural log of x squared plus 4. And now we're going to apply the formula here. And if we look carefully, we're going to see 4 is a squared, so a here is going to be 2. That's going to give us 1/2 arctangent of x over 2 plus our constant, and that is our final answer for this one. One more case to go. It is the one with repeated factors. And just like in the linear ones, we need to repeat our irreducible quadratic, and we do that with the bx plus c, but now we've got this second one over here. We just keep going in terms of letters. So again, this one is nice and neatly factored for us, which is fantastic. We can just go straight to the partial fraction decomposition and then go from there. So let's rewrite our fraction real quick. So now we already have, everything's already factored for us in the denominator. That's great. Easy one, a over x plus x squared plus 1, first power, gets a bx plus c. And x squared plus 1 to the second power is going to give us dx plus e. All right, so now we got 5 letters to deal with. Well, again, to save time, we're going to leave you to do the algebra behind it, but we are going to get a is equal to 1, b is equal to 1, C is equal to -1. D is equal to, oops, excuse me, I am looking at the wrong page in my notes. Let me grab my eraser. All right, let's try that again. A is equal to 1. B is equal to -1. C is equal to -1. D is equal to 1. And E, we get lucky. That's a 0. All right. So now we can set up our integration. We have the integral of 1 over x plus the integral of, well, we have b is -1, c is -1. Let's make that a negative. See how easy you can get away with that? That's going to be x plus 1 over x squared plus 1 dx. And then this last term, we're going to get x squared plus 1 squared on the denominator, and then d is 1, but e is 0, so we get lucky and we just have an x there. All right, so when I look at this, we got to break up this middle one. Fortunately, that makes life slightly harder, but maybe easier. And then, of course, our last integral here. And now we have 4 integrals we have to deal with. This one we know. This one has that formula from the last example. That one's we can use again. These two both are going to have substitution. So your substitution here is going to be u equal to x. X squared plus 1. So du is 2x dx. And of course, 1/2 du is equal to x dx. Same thing, almost the exact same thing over here, which is actually the exact same thing. So we're going to do that again. And now let's get it all in one spot. We have 1/2 here, 1 over u du. Have this guy. And then our last one, which is exactly the same thing. We have 1/2, but now we have a 1 over u squared du. All right, see if we can knock this thing out. Natural log of x. That one's pretty easy. We get a 1/2 natural log, and you would normally say u, but let's back substitute and get the x squared plus 1. Here we have that formula from before, so that's 1. Oh, it's not 1/2. It is in fact just 1, because this time the a is 1. So we have just 1. We don't need to write anything. Arctangent of x. Pretty easy. Minus. Well, we get 1/2 1 over u. This actually becomes 1/2 times x squared plus 1. And there you go. That is the final answer for our last integral. So hopefully you guys found this easy. We can do this in many different ways. This should actually be a negative. And that's it.